Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to start a computer organization and architecture. So in this today's class, I will tell you only the basics. Okay, and join quickly and just let me know whether my audio, video, everything is clear. So please do join quickly and mark your presence, and please just let me know whether my audio, video, everything is clear. Am I audible? Okay, fine. So I welcome you all once again to my session. So that is on computer organization and architecture, COA, under the fundamentals series for GATE 2024. So I have already taken computer networks for fundamental series, theory of computation also I have taken. And please join quickly and just mark your presence. You can just tell me your doubts here in the chat box, and also you can mention your things, whatever the doubts you get after the class also you can mention in the comment box. Okay, so join quickly, and I hope I am audible and visible to every one of you. So please, some of you please type some message, so just say hi or hello in this. Okay, fine. Now coming to, before I begin the session, let me introduce myself. Myself, Murali Krishna Bukkasamudram. I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I am a topper of different NPTEL courses and also certified as International Engineering Educator through ISRO certification program. And I have mentored more than 50,000 students across the country in different core areas of computer science and engineering. So those are theory of computation, TOC, operating systems, OS, computer organization, COA, computer network, CN, digital logic, DL, and information and communication technology. Am I audible? Okay. So, yes, there is a free GATE workshop for complete roadmap to conquer the GATE 2024 by Abhinav Negi sir, and it is on 26th May 2023. So that is today itself. I think it might have been already done at 7:30 p.m. By Abhinav Negi sir. If you have not yet done it, you can just go through that video also, and you can take the scholarship test for getting up to 90% off in the GATE fees, course fees. It will be conducted on 28th May at 12 p.m. That is on coming Sunday. So please try to make use of this golden opportunity to get the scholarship of up to 90% in the course fee of the GATE if you attend this national level scholarship test. Okay, am I audible? So can you confirm me once? Is my audio, video, everything is clear? Yes, fine. Now coming to toppers of 2023 GATE, I think most of you might be knowing, and 2023 GATE students performed very well. We got 62 ranks under 50 and 13 under 10 and 107 under 100. These are the photographs of some of our toppers, and I wish you all the best for 2024 GATE aspirants especially, and also the aspirants of NIELIT 2023. Okay, so these are the actually this success will continue for 2024 and much more rankers will come up. I hope so. Now let's move. And basic functional units. So if you take any computer organization, if you wanted to study, you should know what are the basic functional units of any computer. Do you know what are the basic functional units of any computer? First and foremost thing is CPU. So in the CPU means central processing unit. It's the heart of and the brain of any of the computer system. Okay, so central processing unit. So it contains different entities, functional units like arithmetic logic unit ALU and control unit CU, and also we can have a processor. So this is the processor CPU, and some chip will be there. And also you can have different registers. In addition to that, we can also have the different registers in the CPU. These registers can be either special purpose registers or general purpose registers or both. So special purpose registers are must, okay, and general purpose register may be there or may not be there. That depends on the processor type. In nowadays, all the computer systems will be having general purpose registers also, in addition to the special purpose register. And every one of you might be knowing what is a register. Anyway, I will tell you all the basics here. So these are the basic functional units, and some of the CPUs may also have the chip inside that is called a level 1 cache memory. So level 1 cache memory also can be a part of this processor. That's why level 1 cache memories are called on-chip cache. So it can be an instruction cache or it can be data cache. Hope you are following. And memory is placed in between, okay, CPU and also IO devices. Okay, IO devices are input devices and output devices. Okay, so computer system input devices, output devices, you know very well. So keyboard is an input device, monitor is an output device, printer is an output device. Okay, and whatever the input, say joystick and input that is taken, that is all comes under the input device. For example, writing pad is also input device. So I am writing on a pad, so that is also input device. And so there are different peripheral devices that are connected to the computer. So all these comes under the IO devices. Okay, and we need to have a communication among the IO devices, and also we need to have a communication among memory to IO devices and also from CPU to IO devices. So for that, some common bus system is required. Okay, so bus is nothing but it is a medium in a computer where we can transfer the information from one device to another device. Okay, maybe from memory to CPU or from CPU to memory or IO devices to memory, memory to IO devices to and fro. So for all these things, we use the common bus system. Hope you are understanding. So please make your comments here. So none of you are actually responding here in the live chat. Am I audible? Please respond somebody. Am I audible? And before you can just proceed, you do subscribe the channel, and also please do like the session if you are really liking it, and press the bell button for getting notifications related to your classes. And we are providing a lot of series on the YouTube for the GATE, NIELIT, ISRO and all. And please try to make use of this free content. Okay, every day some classes we are providing. So both technical, non-technical, general sessions, guidance sessions, all those things. Okay, fine. So these are the different basic functional units of a computer system, right? You have any doubt? Am I audible? Visible to every one of you? Please confirm me once. Okay, fine. That's great. Okay, now let's move. Fine. What is the difference between computer organization and computer architecture? So most of you might be having this doubt actually. So COA, computer organization and architecture. Computer organization is the way in which different functional units are connected and how we are organizing them. Computer architecture deals about the functional behavior of each and every component, how they behave and how to design them. Okay, CO, computer organization, the way in which different functional units of a computer are get connected and how we organize each of them, like how we organize memory, how we organize CPU, how we organize IO devices. Like that, chapters are defined like IO organization, memory organization, CPU organization, and based on the organization of CPU, instruction formats are decided. Based on the organization of memory and memory interface is decided. All those things. The way in which the different functional units are connected and how we are interfacing each of them. That is what computer organization is. This is a basic fundamental thing one has to understand when you are studying the computer organization and architecture. And in general, most of the engineering students will have a myth that computer organization is very difficult subject. Not at all. So computer organization is very easy if you are thorough with the basics. Okay, and you have to study the computer organization in a proper sequence. If you follow the proper sequence and if you follow all the classes, if you learn all the contents from the basics onwards, you can easily crack the 100% marks in the computer organization. It is not so difficult. Okay, once if you pay your attention. Okay. Now let's move. What is a computer architecture? It is a study of a functional behavior of each and every component. For example, if you wanted to design ALU, so what type of requirements are there? What type of operations to do? Based on that, we can design ALU. So certain ALUs cannot perform certain operations. So if you define an ALU in such a way that the operations are performed, Then based on the operations performed by the ALU, we define the opcode of a computer system in instruction format. Instruction format will be having opcode and address parts, right? So opcode, the bits of the opcode, machine code of that opcode, zeros and ones are decided based on how you design the arithmetic logic unit, based on the number of operations that ALU is performing. Hope you understood. Okay, now shall I go ahead? And none of you are asking any question. I think all of you are very familiar with the basics. Is it so? Okay, fine. Now let's move on to the next slide. Do you have any doubt regarding the difference between computer organization and architecture? And what is a computer design here? Design is something like defining a new computer system or making arrangements for designing a new computer system by using the different requirements. So according to the requirements, designing of a new computer. So when the requirements are changed, we have to change the design. Say for example, you wanted to execute some tough instructions. So accordingly, we have to define the architecture. And accordingly, we have to define the components like ALU, CPU, all those things. Okay. So here in today's lecture, I wanted to give you a brief analysis on the basic aspects like what are the special purpose registers we use, and as you already understand, what are the basic functional unit in a computer. Okay, now let's move. What is a register? What do you mean by register? A register is nothing but it's a group of flip-flops. A register is nothing but it is a group of flip-flops. So what do you mean by flip-flop? So flip-flop is nothing but it's a binary storage cell. Say for example, we are having a register like this. So an n-bit register containing group of n flip-flops. So each flip-flop is having capacity of storing 1 bit of information. Is having a capacity of storing 1 bit of information. For example, it is a 5-bit register. Okay. So let us suppose this is a register R having 5 bits. That means there will be group of 5 flip-flops. So it can store only 5 bits of data. It can store only 5 bits of data. So registers are part and parcel of CPU. Okay, and within the CPU, these are recited. And registers are of two categories: GPR, that is a general purpose registers, and then SPR, special purpose registers. General purpose registers and special purpose registers. Special purpose registers are meant for specific purpose. We can't use them for any other purpose, like they are designed for making use for that purpose only, like program counter stores address of next instruction, like that. So we can have different control inputs for a register, and we can also have different data inputs. For a 5-bit register, if you wanted to parallelly load the data, so there can be 5 data inputs, and there can be different control inputs. Those control inputs can control the total operation of register. Like load control input, whether to load or not to load, it is decided. And a clear control input to clear the content of register to zeros. And also increment control input in order to increase the register value by 1. Say for example, initially a 5-bit register is containing 5 zeros. Okay, when you load some data, either parallelly or serially, parallelly means all the flip-flops are filled at a time. Serially means we can shift either from left side or from right side, we can store the data like one bit by bit. Parallelly, all the bits are loaded at a time into the register. And whose organization is actually it is a sequential circuit, whose organization is monitored, or you can say controlled by these control inputs. So why these control inputs are required? If you have a load input, for example, if load is equal to 1, it will accept the data, otherwise it won't accept, no change of the content. If load is equal to 0, that means it won't accept any data. If load is equal to 1, it will accept the data from outside. And if you wanted to clear, for example, right now the register is containing 11010, for example. After making the clear input high, you will get all the flip-flops clear to 0. It will become 0, 0, 0, 0 like this. And increment input, so it is increased by 1. So R becomes R plus 1. Whenever increment value is 1, this control input is 1, the content of register is getting incremented by 1. So that is what is a register. And in computer, basically special purpose registers is must, and some computers, basic computer may not have general purpose register, but every computer nowadays which you are using are having the general purpose registers for more storage of data, for quickly accessing the information and doing the operations. Okay, now if you have any doubt, please don't hesitate. Please ask your doubts. And what is a special purpose register actually? So there are in a computer definitely some set of special purpose registers are required. Without these registers, it is impossible to perform the operation. Like PC is a program counter. PC is nothing but it is a program counter. So program counter here, it stores the address of the next instruction. For example, if you wanted to execute a program is nothing but what? Some set of instructions. And when you write a program, your program is compiled, and after compilation, machine code will be generated. If you want to run the program, this machine code should be loaded into memory. Okay. So in the memory, for example, program containing 100 instructions, we have to execute instructions one by one as per the sequence mentioned in the program in high level language. For every high level language, we have to convert into machine code by the compiler, because computer cannot directly understand the high level language program. Yes, Siddhant Sharma, the value stored in the register will be increased by 1 exactly for the increment operation. Siddhant. Siddhant. Very good question. The content will be incremented by 1. For instance, I will tell you here. For instance, let us suppose the register R is containing the value 00001. Okay, once if increment input has been enabled, then INC or IN or something like that, the next value will be 00010. That is how register is getting updated. Some manipulation can be done. Okay, now coming to these special purpose registers, I will try to explain here in today's session why this special purpose is required. And if no special purpose register is there in a computer, then computer cannot be operated. My friends, I am sure, so you can just ask me any question on this. If you wanted to operate a computer, okay, so definitely in a CPU, registers are placing a major role, especially SPR. That is a special purpose registers. And every register is having its designated work. So what is that? For example, program counter. Program counter stores the address of the next instruction. Simply it is a PC. Okay. And MAR, it is called memory address register. Memory address register. Or simply some representations also says that simply address register. So memory address register. Okay. Now, actually, if you talk about the program counter, let us suppose in a memory, so if you store some instructions like this, maybe a first instruction, second instruction, third instruction, and so on, some 100 instructions are there. And every instruction is having some address. This is the memory, for example. Okay, this is the main memory. Which address it is? Main memory address, not other addresses. Say, for example, instruction 1 is available at address 200, instruction 2 is available in memory at address 201 and at address 202. Like this, the instructions are stored. For instance, then we have to get those instructions one by one. This is 202 is the address. Okay. So after getting these instructions, we have to execute. Where we will store these instructions after fetching? So at 202, instruction 3 is there. Like this, we will store. So initially, first instruction address, PC is loaded with 200. When you take this instruction and fetching is done, then PC is pointing to next instruction always. So that means PC will be incremented. So it will be pointing to 201. Always it will have an address of the next instruction to be executed. We refer only the PC for knowing the address of the next instruction. And PC keep on updating based on the sequence of the program you are getting executed. Yes, Siddhant, instructions are necessary stored sequentially in memory. Yes, but usually we store in a sequence. Okay, but when there is a function can be loaded into some other location also. And whenever a function is called, we go to the location of the function and execute it and come back like subroutines. But normally from main program onwards, all the programs instructions are stored in sequence only for execution, because hardware is designed in such a way that when the first instruction is taken, In some implementations, next instruction, if it is not a branch, next instruction will be immediately followed by the present instruction. If it is a branch, means you may jump to some new location also, like some program control instructions. Siddhant, I hope you understood. Okay, na? Next, MDR is nothing but memory data register. So there is a difference between address register and data register. Memory address register actually stores the address of the either instruction or data. Finally, you go to the memory to get any content, any word of memory we can access only through memory address register. Memory data register is to keep the data that is fetched from the memory. Okay, because in a memory we can store the instructions as well as data. Okay, at the time of fetching instruction, we refer to PC. Through PC, we get the instruction because PC knows the address of the next instruction. After getting the instruction binary code from memory, we have to keep in a CPU in some register that is called IR. IR is a instruction register. It is used to store the binary code of instruction that is taken from memory. Instruction register. This is a special purpose register to store the binary code of instruction. Okay, and while you are executing instruction, data is required now to perform some operation. For example, addition you wanted to do. For addition, 2 operands are required. So when each operand you are fetched from memory, if operand is available in memory, that is a data, then that data first you have to keep in the memory data register. Then we can perform operation through ALU. So whatever the instruction you write now in the computer, instruction opcode will instruct the computer to do certain operation. Operation code is nothing but instructing the computer to do certain operation. That means it will give instruction to ALU to perform that operation. So that operation is done by exactly the ALU, but operands are required to perform the operation. Operands either we can take from general purpose registers if they are available, or from memory. But if you take anything from memory, first, either as far as the data part is concerned, you have to keep it in the memory data register. Okay, now, are you okay with this? Now, do you have any doubt or any concern? Please let me know. And AC is nothing but accumulator register. Accumulator register. What do you mean by accumulator register? Accumulator register is a special purpose register. So whenever you need any operation to do in certain organizations, CPU organizations, like for example A plus B you wanted to do. First A value we can take into accumulator, B value we take from memory and then add it to accumulator. Again result is accumulated to accumulator register. So that is what. So this INPR is nothing but input register. Any input character taken from input devices will be first kept in the input register. Through input register only we will give it to computer. And if any output you wanted to display either in monitor or in the printer, so output register, through output register output characters are being sent. Okay, TR is a temporary register. So any temporary data is there, okay, to store, we can use this TR register. The size of these register depends on the memory size you have and also the instruction size you have. The size of the register depends. And for performing some indexing operation, XR is also used. That is called index register. So to perform array indexing and all, index register is also required. And SP is the stack pointer register. If a computer uses the stack, memory stack or register stack, so to know the address of the top of the stack, so stack pointer register is required. Stack pointer register always pointing to the address of the top of the stack. Stack point register always points to the address of the top of the stack. Are you following? And if you get any doubt, please don't hesitate. And meanwhile, please share this class information with your friends and also do subscribe the channel, this GATE YouTube channel, Computer Science, and also you can do like the session and press the bell button for getting notifications. Okay, fine. Do you have any doubt on these registers now? Why SP is used? Stack pointer for storing the address of the top of the stack, for getting the any element. To update the stack pointer as and when some push operation or pop operation is performed in the stack, and index register to implement some of the index operations, TR for temporary data, input output for IO devices, and accumulator is for ALU. So whenever ALU want to perform operation, output of ALU is by default loaded into accumulator as a result in some implementations, some basic computers. Okay. So special purpose register will be like this. Actually, one example I will tell you how the accumulator is used. Let us suppose in a particular programming language you have simply written like C is equal to A plus B, and you declared A as integer variable, B as integer variable, C as integer variable. So actually what happens is A value, let us suppose A value, B value, C value are available in memory. Only memory operands we are using, for example. There were no general purpose registers. Yes, Siddhant, how many classes are planned for COA in the YouTube? Very good, Siddharth. Actually, I planned around 6 to 7 classes. So I will consider instruction pipelining completely I will teach, followed by catch organization I will teach. So tomorrow instruction pipelining I will teach. All of you try to make use of this facility. And some instruction formats, addressing modes, I'm not covering in this series. I'm covering instruction pipelining, the most important topic, and followed by some catch memory organization. Every day I will share the details of the class in the Telegram group if you are available in my Telegram group. Otherwise, please do join. Okay. So accumulator is a register. Why it is used, I am just explaining. So if you declare int a in a C language, for example, associated with integer a, address a, some 2 bytes of memory is allocated. Int b associated with address b, some 2 bytes of memory is allocated. Int c associated with address c, some 2 bytes of memory is allocated. So this is the data portion of memory. So to this simply we write in high level language, but when you write in the machine code, what happens is, first of all, in some architecture, because when the computer is changed, entire instruction formats and everything will be changed. So LDAA means we have to load the accumulator with a value A. So that means as a result of this instruction, accumulator is loaded with a content of memory at address A. That is a reading the A value. And then directly we can write add. LDA is a mnemonic code, intermediate code. Definitely some binary code will be there, zeros and ones. You need not remember any of the thing here, just you see what is happening. Add B is nothing but already accumulator is containing one value, that is A value. So that is content of accumulator plus content of memory at address B. That means A plus B value is there in the right now AC. We have to store here in memory at address C. So for that we can take STAC. STAC is nothing but go to memory at address C, and whatever is the content of AC, that we have to store in memory. So these are the 3 instructions required. That's how we will make the high level language program into machine code. This is intermediate code, of course, assembly code, and for every intermediate code there will be some machine code. From computer to computer it will vary based on the hardware structure, based on the architecture of the system, based on the ALU operations it does, all those things. Hope you are following, and except Siddhant Sharma, others are not asking any doubts. Please try to make use to ask your doubts, and please maintain the continuity of classes till this YouTube series is finished. So around 7 classes, I will tell you, update the details. If required, I will take additional classes also. Don't worry. Fine. Now let us move. General purpose registers. General purpose registers is like this. So there is no need of for any data to store. For quickly accessing we can use, and we can name them like R0, R1, okay, R2, like this. And every general purpose register will have some address. For example, in a computer, I am maintaining 64 general purpose register, for example. So those are numbered from R0 to R63. That means every register will have address. R0, 64 means it is a 2 power 6, a 6-bit address is required. 000 000 is R0. And R1 is nothing but 000 and R2 address is like 000 Even for special purpose register also address will be there, and so on. R63 address will be all ones. like 11111. So why these general purpose registers are used? For example, in the previous example, I went to memory for getting the A value. For example, A value 50, B value 60. First 50 is loaded to AC and 60 is added to 50, so 110. So finally 110 is stored in memory at address C. That is how, that means every time if you go to memory, access time is more. So to reduce the time to perform operation, finally, if you make the data available within the CPU in the general purpose register, it is very easy. So it is something like this. For example, if you write C is equal to A plus B, for example, every time there is no need of going to memory. If the A value made available, B value also made available in register. Sometimes we may write like this. So something like add R1 comma some R2 comma R3. If I write a 3 address, so let us suppose R1 is equal to content of R2 plus R3. This instruction is given like this. So directly we access the data of register R2, data of register R3, both are added in the ALU, result is stored in R1. So quickly we can access the data from registers rather than going to memory every time. For that purpose, for making the process of performing operation quicker, we have to go for this type of general purpose registers. So any computer with more general purpose registers is more efficient and also it is faster in the execution. Okay, now any doubt is there? Please let me know. And what is a computer instruction? Computer instruction is nothing but it is a binary code for instructing the computer to do certain operation. So that's why any computer instruction is containing opcode value, means operation to be performed, followed by address part. Address may be a single address or two address or three address. This address part will define where the operands are available, address of the operands. Sometimes operands may be available in memory, sometimes operands may be available in registers, sometimes address part itself is containing operand rather than going to memory or this instruction itself. It's all depending on the mode of addressing. Opcode is nothing but operation to be performed. Operation to be performed by the computer. Operation to be performed. What operation? Addition, subtraction, division, multiplication, whatever it is, or transfer of data, anything. It may be a normal arithmetic operation, or it may be a logical operation, or it may be a shift operation for shifting the data, or it may be a data transfer moving from one register, like something like this. Say, for example, if I am writing move R1 comma X, so it means that R1 is a destination register. I am taking one memory data at address X. I am going to memory at address X, and content of memory at address X is being transferred to register R1, loaded to register R1, something like that. Or you may have arithmetic operations like add, maybe R1 comma some X. It indicates that R1 is equal to R1. One content of register is one operand, content of memory at address X is one operand. These two are added and result is stored to R1. Sometimes I am writing two operands, sometimes I am writing one operand, memory operands, register operands. It depends on architecture. Architecture to architecture it differs. So when you study about a particular architecture, that computer instruction completely we discuss about that particular architecture, including the binary codes. Yes, sir, it's a three address instruction. Yeah, earlier it was three address instruction. Now it's a two address instruction. A statement written in machine language instruction. Exactly. Statement written in this is only explanation. So after the colon, semicolon, I am written semicolon R1 to M of X means this is how operation, what operation is performed, where the operand is stored. I am just making a comment there. Comment. Okay. So usually the basically one instruction format is there for a basic computer. That instruction format is containing mode of operation is I, indirect mode or direct mode, followed by opcode, followed by address. So in a basic instruction format, in a basic computer, this address part is always indicate a memory address. So how much memory address bits depends on the memory size. And this opcode part indicates what operation it performs. and this is a mode part. This mode part indicates whether you get the operand directly or indirectly. So direct mode or indirect mode. So I is equal to 0 means not indirect, it is a direct. I indicates indirect, like a pointer. And I value 1 indicates it is the indirect mode. Indirect mode in the sense through the pointer. Okay. So this is what direct and indirect modes are, Siddhant Sharma. We are having like, let us suppose I will explain. For example, 0 ADD 500. It means that AC is equal to content of AC already there and content of memory at address 500. That means if you go to memory at address 500, directly the operand required for you will be available. This is the memory. Okay, if I go to memory at address 500, for example, there is an operand. That operand is available. Let it be, it is 600, let us suppose. The operand is 600. So in that case of direct addressing mode, this 600 is added to the accumulator. This is called direct mode. In the case of indirect mode, it is a pointer to the effective address. So what is effective address here? 500. Effective address means where the operand is available. Okay, if I say 1 ADD 500, so 500 is address part, ADD is the opcode part, and I value is indirect bit. So here AC is equal to AC plus, I hope Siddhant you are following, M of 500. So M of 500 means if you go to memory at address 500, 600 is there. No, again you have to go to memory at address 600. So two references are required. Let us suppose content of memory at address 600 is 700. In the second case, M of 500 is 600, again M of 600 is 700. 700 is added to accumulator. In the first case, 600 is added to accumulator. That makes the difference. In the first case, effective address is 500. In the second case, effective address is 600 because operand is available at effective address 600. Okay, na? Hope you understood the difference between direct and indirect. This is used only two formats of direct and indirect in a basic instruction format that is used by a basic computer. Okay, so that is what addressing mode here, and you take one problem you will understand. Just to have a practice, I brought this problem. The content of accumulator register is 200 initially. Let us suppose accumulator register, the value present is 200 and the contents of memory at address 500 is 600 as I told you. Content of memory at address 500 is 600 and the content of memory at address 600 is 250. What is the value of accumulator register after executing the following one address instruction? So this is nothing but AC is equal to AC plus M of 500 na? Because it is indirect mode. So M of 500 is nothing but 600. Again M of 600 is 250. So AC is equal to AC plus 250. So what is AC? AC is already containing 200. So 200 plus 250. So it will be 450. So option D is the right option. Exactly. Siddhant, you are correct. Okay. So that's all for today. And which of the following is not a part of CPU? Register is a part of CPU. Control unit is a part of CPU. Level 1 cache also part of CPU. Level 2 cache is outside of the CPU. So actually level 2 cache in between the CPU and memory it is placed. Level 2 cache is also called as L2 cache. And L1 cache is a part of the CPU only. And in between memory, main memory and the CPU, this L2 cache is placed. Okay, na? So these three are parts of the CPU, but level 2 cache is not a part of CPU. And you can just take this as a homework problem. Okay, so you can about this problem, if you have any doubt, and in the comment box you can ask. I will tell you the answer to this. Okay, I have already spoken about a program counter today. Yes, Sharma, what is your doubt? When we use indirect, it will take More time. Yes, exactly, Siddharth. Because two memory references are required. It's like a pointer. In a pointer pointing to integer variable. So int p, int star p, there is difference, no? Int star p, we require two memory references. Int p, we require only one memory reference for getting the data. Siddharth. Okay. So that's all for today. I hope you people really enjoyed the session. Thanks a lot for attending, and please do share this information with your friends. And please attending the classes of computer organization and architecture till this series is finished daily at 9 p.m. Okay, next class will be on Monday. So let's meet on Monday. Thank you so much. See you all once again. Bye bye.